In this chapter, we're going to start looking at arrays. We're going to start out with single-dimensional arrays. Before we do that, we should probably talk about what an array is. So, why would we need to use an array would be the question we want to ask ourselves first. So, here's our opening problem. Let's read 100 numbers in. Then compute their average and find out how many numbers of those 100 are above average. That seems all well and good. If I said 3 numbers, we could create 3 variables. Ask the user to input 3 numbers, and we could add them up, divide them by 3, and compute the average, no problem at all. But that problem doesn't scale up very well. That solution doesn't scale up very well. If I raise that to 10 numbers, then I have to have 10 variables. If I raise it to 100 numbers, then I have to have 100 variables. And you can see the problem. As we go on and on and on, we're going to have more variables. Our code's going to get really long and really repetitive, and that's what we do not want. The solution to this is to use an array. An array is a data structure that represents a collection of the same types of data. Okay, so what does that mean? I can create a variable, like in this case, our variable is called myList, okay? And I can assign that variable multiple values. So I like to think of it as a box. So think of it as a real box, like a giant shoebox. And we divide that shoebox up into compartments. So we have a compartment here and a compartment here, and there's a compartment and another compartment. And we have all these different compartments, and it's called myList. And we can access each compartment by a number that's been put on that compartment. So in this case, we have a 0. Element 0 is this first compartment, and it has a 5.6 in it. Element 1 is this compartment, and it has the value 4.5 stored in it. Element 2 is this compartment, and it has a 3.3 stored in it, and so on and so forth. In this case, myList is a variable that was set up to hold doubles, okay, and it can hold, in this case, up to 10 doubles. And we start here with myList sub 0. That's how we read this, myList sub 0. Okay, and it goes up to myList sub 9. So our 10 compartments in this variable called myList are numbered from 0 to 9. That's 10 numbers. If you count the 0, that's 10 numbers. So we always use 0 numbering when we use array indexes. So the number that's inside of these square brackets for myList is called the index number. And we can access each of these compartments by using the variable name followed by the square bracket with the index number inside it. So if we want to look at the array element at index 5, here is myList sub 5, and we can see the element's value is 34.33. Now, one thing to understand about the variable here is that it is a reference variable, and that's going to become very important later on. So myList is a reference variable. It's like the variable we would use to hold a scanner, because an array is an object, like a scanner was an object. So myList is a reference variable that points to a location in memory where the beginning of our array begins. Once we create an array, we can't resize it. So this array that I've created here called myList has 10 doubles. And because of that, it can never have more or less than that. It's always going to have 10 doubles. When we declare the variable, the compiler sets aside enough memory to hold a double, in this case, times 10 doubles. And the reference points to the beginning, and then we can multiply by the size of each one to find the beginning of each different value. That all happens behind the scenes. So that when we access the array at index 5, it can take 5 times the number of bits in the data type add that on to the beginning address where this is stored, and it will automatically find the address where mylist sub 5 happens. Now, we don't have to worry about that. All we have to remember is the index numbers, and the compiler will take care of the rest of it. But know, once it creates this array, in this case it's called mylist, it is fixed in this size. It can never get bigger and it can never get smaller. It will always have 10 values, and in this case it will always be doubles. So anytime we create an array, it's always going to be of the same type all the way through. So this is an array of doubles that is 10 long. It will hold 10 double values numbered from 0 to 9. So let's examine this statement here a little bit more detail. How do we declare an array variable? We have to name its data type, followed by the square brackets. Okay, and the square brackets designate that this is going to be an array of whatever data type we put here. And then we have to give it a variable name. And this isn't really any different from declaring any other type of variable. If we declare an int, we name its data type, and then we give the variable a name. Okay, so in this case, we're naming the data type, but we're saying it's an array of that data type, and we're giving that array a name. So example, hey, this is an array. I can tell that by the square brackets. It's an array of doubles called mylist. Okay, now there is one other way to do it. We can say double. Okay, we can say double here, and we could say mylist and put the square brackets at the end. So that's this way: data type with the array name, and the square brackets over here. But it's kind of not standard. You really shouldn't do it that way. This is the generally accepted way everybody does it. Okay, so if you see it like this, technically it will work, but it certainly isn't convention, and it certainly isn't standard. Put the square brackets with the data type, so when people read this, they can see right away it's an array of doubles. Okay, if I'm glancing down through code, I might not notice this is an array of doubles because the brackets are clear down here. So that's how we declare an array. We also have to create the array. I mentioned before that it's an object, kind of like scanner is an object. And when we create a scanner object, we always have to use that keyword new. When we create an array, we also have to use the keyword new. So we use the keyword new followed by a data type, and then we have to give it the size of the array we want to create inside the square brackets over here. So I can say a new array of doubles of size 10. I want this to be an array that holds doubles, and I want it to hold 10 doubles. And that creates the object in memory, and the assignment operator assigns it to this variable. Okay, and then we can access the elements in the array using their index numbers 0 through 9. Now, I showed you two different things. I showed you how to declare a variable here, and then we talked about creating the array and assigning it to the variable there. That's two separate steps. But actually, we can do it in one step, and we do it like this. We're going to declare the type with the square brackets, give it a name, and then use the new keyword followed by the data type and the size. So that's what we saw in that very first slide. We've declared on the left side here, we've declared an array called mylist that's an array of doubles. On this side, we've created a new array of doubles. Okay, we've created the object in memory and assigned it to the variable we declared on the left side. So we've seen it do that with ints, and we've done it with doubles in the past. Now we're doing it with arrays, creating and assigning it and declaring it all at the same time. Down here, you can see that alternate method. We're still creating the new array down here. They put the brackets, the braces, on the right side instead of with the data type. Again, not a preferred way to do it. You should not do it that way. So the array elements, those individual boxes within the array, those individual compartments, are accessed through the index number. And the indexes are zero-based. The indices are zero-based, meaning we start numbering them from 0, and the numbers will go up to the length of the array. And we're going to learn about this length thing because it comes in very handy. We can get the length of the array minus 1 will be the index of the last one. So in that original figure we looked at, my list held 10 double values, and we saw them numbered from 0 to 9. Each element in the array is represented using the syntax, the name of the variable, and inside the square braces, we have an index number. So to use them, we can use them just like any other variables. I can take my list sub 0, and it will get the value out of the 0 compartment, the 0 index of my list, and the value out of the index number 1 compartment for my list here, and it will add those two together and store them in my list sub 2 if I wanted to do that. So using variables with indices on them for an array are no different than using any other variables. We can also test for the length of an array. So we can use the name of, anytime we want to know how long the array is, we can use the name of the array and its dot length property, and it will tell us how long the array is. So if I would do that original problem, my list dot length, it would tell us that it is size 10, that it holds 10 numbers. And that's going to be it for this chapter, or this video, not for this chapter. There's a lot more to come in the chapter. In the next video, I am going to do a live example. We're going to create an array and go through it and take a look at it inside NetBeans.